Hiya, it's Carly from Kip McGrath in Carlisle, and we're back on maths today, so we're looking at prime numbers, factors and multiples. I am going to briefly touch on lowest common multiple, but I'm not going to be touching on highest common factor because it does require quite a bit more. If anybody has any specific requests for me to do that one, that's absolutely fine. I'll happily do that a bit later on. Okay, so these three things are all about identifying types of numbers. And these are things that children are often asked to identify. So, prime numbers. How do we decide if a number is a prime number? So the key rule is that it will have two factors, and those factors have to be itself and 1. So only two factors. So that's our first thing. So it has two factors. There's one extra thing that people don't always know. So 1 is not a prime number. For that reason, because 1 only has one factor, so 1 is not prime, okay? The only even prime is 2, and that's it. There'll be no other even prime numbers. So those are just a few little facts about prime numbers. And then when it comes to actually deciding for any given number whether it is prime, we only ever need to check 4 times tables if that number's below 100, which for most children in the types of questions they're going to get is the type of number they're going to deal with. Okay, so when we check the 2 times table, that also checks the 4s, the 6s, the 8s, the 10s, anything like that. So once I've checked 2s, that's all even times tables covered. And if it's in the 2s and it's even, it cannot be a prime number unless it is 2 itself. Okay? So we can quickly eliminate any even numbers as prime numbers except for 2. Okay, another thing that we often are asked to check is the 3 times table. Now there is a really good trick for checking whether something's in the 3 times table, and that trick is to add up the digits of the number. So for example, if I had 36 and I add up the digits, so I add up 3 and 6, I get 9. 9 is in the 3 times table. 9 is a multiple of 3, 3, 6, 9. And so therefore 36 is also a multiple of 3. So if the digits add up to a multiple of 3, it's in the 3 times table. So we can apply that to even bigger numbers. If I was to add that up, 7, 8, 9, 10, 11, 12, 13 adds up to 13, not in the 3 times table, and so therefore it's not a multiple of 3. Okay, so that's how we can test if a number is in the 3 times table. 5 times table, dead easy. Children will learn this very early on. Will end in a 0 or a 5. So any number that ends in a 0 or a 5 is in the 5 times table. 7 times table is a little bit more tricky, but obviously as it's a bigger times table, you get almost all the way up to 100 just by counting in 7s, because obviously we get to 70, 77, 84, because we tend to do 12 of everything. And so there's only a few more 7s to actually count on to work out the last few that are in the 7 times table. So whenever the children are given a number, all I tell them that they have to do is to test those 4 times tables. Okay, so if it's not in the 2s, the 3s, the 5s, or the 7s, it's prime. So not in any of those, it's prime. And that's a good way to work out whether something is a prime number. And I would tend to start with them in that order. Okay. Factors then. So factors are all about numbers that go into a number. So numbers that go into 36. And generally when they ask for factors, they want them in order. So the nicest way to do it is to start at the bottom, do them in pairs, and then write your list out afterwards. So if I was writing the factors in pairs, always start with 1. So 1, and what is 1's partner? Well, it's 1 times 36. Okay? Then I'm going to move on and I'm going to try 2. So does 2 go into 36? Yes, it's even, so it does. Half of 30 is 15, half of 6 is 3, 15 add 3 is 18. So that's my next pair. Does 3 go into it? Yes, because I know my 3 times table. 3 times 12 is 36. Does 4 go into it? Yes, again, 4 times 9 is 36. And then I would encourage the children to carry on in number order down this side. 5. Does 5 go into it? No. So I cross out 5. Next one is 6. 6 times 6 is 36. Okay, So that is my last pair, because once these two numbers that are at the bottom are next to each other, I don't need to go any further. So I don't need to go any further at this point. When I was then writing those in a list, I would remind the children that they would never write the number twice. So they just write 1, 6 when they're writing them in order. So if I was writing those in order, I would just go 1, 2, 3, 4, 6. So I've gone down here, and then I work my way back up this side. So 9, 12, 18, 36. Another little aside on the factor side of things, sometimes children are asked to write up a factor tree. Okay, so a factor tree is really useful for identifying prime factors. And those prime factors, once we get to them, would times by each other to get back to the original number. So for 36, what we're looking at is factors. So at this point, I am splitting it into two numbers that times by each other to get 36. And I could use any of those. I'm not going to use this one because it doesn't get me any further along. I could use that one, I could use that one, I could use that one, I could use 6 and 6. It is entirely up to me. I will still get to the very same end result. So I'm going to go with 3 and 12. And when we're doing prime factors like we are now, we're looking for the end of these branches to be prime numbers. 3 is a prime number because it doesn't divide by by any more than 2 factors. So I'm going to circle it. And then I'm on 12. Well, 12 I know does have other numbers that go into it. So what numbers go into 12? Well, we can have 2 and 6, or we can have 3 and 4. I'm going to go with 2 and 6. So 2 I know is the only even prime number, so it gets circled. 6 is not prime, so it gets split up further by 3 and 2. And at that point, we've got all prime numbers at the end of our branches. And when we come to write our prime factors, we start off by putting them in number order. So we're going to have 2 times 2 times 3 times 3, which can be simplified to 2 squared times 3 squared. And if I put that into a calculator, the answer would be 36, because that's the whole point. So that is using a factor tree, and this is our prime factors. Okay, so that's all your factor sort of side of things. Then we can move on to our multiples. Related to factors but different. Multiples, think about multiplication tables. So a multiple of 3 is every number in the 3 times table. A multiple of 4, every number in the 4 times table. And it is just as simple as that. So it's times table based. Now the reason I've then mentioned lowest common multiple is because sometimes you get asked for the lowest common multiple of 2 numbers. And that's the lowest multiple that is in both of the times tables. A common one is lowest common multiple of 7 and 5, for example. And what I would do there, certainly on easier questions, when we get onto harder questions, this links into the highest common factor stuff, which I'm going to cover a different day. But when we're on easy ones, what is our lowest common multiple of these 2 numbers? We would literally just encourage the children to sit and write down their times table. So 5 times table, go as far as 10. So that's 10 times 5. Do the same with our 7s. And usually, as they're doing that process, they would identify the lowest common multiple. So we're looking for the lowest number that's in both. So you're working your way along. None of these are in both, none of these are in both, until we get to 35. So our lowest common multiple of 7 and 5 is 35. And that's just an introduction to prime numbers, factors and multiples. And as I've said, I will look at lowest common multiples and highest common factors on a different day. Okay, thanks.